Hello everyone, welcome to my YouTube channel Jankcast. Today we will look at a question which has been asked in Google technical interview. So this question falls under the category array. So let's dive into the question. You have two integer arrays a and b and an integer target value v. Determine whether there is a pair of numbers, whether one number is taken from a and other from b that can be added together to get a sum of b. Return true if such pair exists. So basically, like we need to check the array, first array and second array, and one value from the first array and another value from the second array. When we are going to sum it up, it yields this value 42. If it's equals to 42, then return it as true. If not, return it as false. So this is the question. So basically, like so what in general the brute force approach will be like, we'll be having two for loops, one inner for loop, one outer for loop, and then within the inner for loop check the array for two arrays and validate the total, and if the total equals 42, then return it as true. If not, false. So that is a brute force approach. Let's check this brute force approach first. So for let x equal to 0, x less than a dot length, x plus plus. Now again, like for let y equal to 0, y less than e dot length, y plus plus. Now say like if v equal to a of x plus b of y, then return true. At last make it as return false. Let's check this output. So true. So if we are going with this approach, so this may call like brute force. So the time complexity will be O of n times O of n squared. So the time complexity is O of n squared. How about going with an optimized way? So let's let's check with the optimized way. So you might have one more question, like how about like instead of making this for loop, instead of maybe I'll show one more approach. So we'll have this one, second approach. So second approach, like instead of having this for loop, let's assume like we check if b dot includes b minus a of x So this is also one more approach to solve this problem. So what we are doing, like we are subtracting 42 minus the first array, and if any of this value available on the array b, then return true. So this method, I'm sorry, like so okay, so this should be true. So by doing this method, we are again going with the same time complexity of O of n square. The reason for that is like so includes the method array dot includes is again O of n. So it's going to be like O of n of O of n, then it's going to be O of n square. So the second one is also not an optimized way. So the best optimized way is like to go within the set operator. So the optimized solution will be, let's make this as solution 3. Okay. So the second approach, let's refactor the second approach. So what we'll do, like, instead of this B, so we'll make it as a set operator, new set of B. Okay. So now what happens, like, all this B will have like so the B value will have in an index like 0, 1, 2, 3, 4. And now remove this one and check, like, and make sure, like, if B dot has B minus A of X, okay. So what it does is, like, if B, so here when we say like B of set B, let's see here. Maybe we can see how it is. Let's see. So my B is, so how about like B equal to new set of B. Okay, so now I have all these values like 10, 20, 30, 40. So what it does is, like, if B dot has 40, so it looks for the remainder value. If it is available, then return it as true. True. So this optimized way will fall under O of n. And here the time complexity will be, I think this time complexity is, so the time complexity is O of n, and the space complexity will be O of n. The reason is, like, we are storing this value B at a new place. And for the brute force, both these approaches, the space complexity will be O of 1. Hope you have understood the problem. If you have any questions on this particular problem, please feel free to share your comments in the comment box. If you like this video, please like this video. If you don't like this video, please dislike this video and share your valuable comments for better improvements on the coding exercises. Thank you. Thanks for watching this video. We'll meet soon.